Hello everyone. In this video I'm going to be looking at simplifying complex numbers, in particular dividing them, which in this case comes in the form of a rational expression, 3 plus 5i over 10 plus I. This is referred to as, or at least I refer to this as the second type of dividing by complex numbers. The first type is where I have a single term in the denominator with an I. The second is what we see here, where I have two terms in the denominator, one of which has an I with it. So to solve one like this, to simplify or divide, means the same thing in this case. I'm going to first use what's called a conjugate. Conjugate comes from this rule of factoring. If I have a plus b times a minus b, that multiplies that to a squared minus b squared. These two, a plus b and a minus b, are referred to as conjugates. Meaning they have the same two terms, a and b, but different middle signs. What that means is, to simplify this, I'm going to look at my denominator and I'm going to identify that I have two terms, one of which has an I, and I'm going to automatically go to the conjugate, which is going to be 10 minus I. And I'm going to multiply that to my numerator and denominator. Now to simplify this, to shorten it up, I can take my denominator, which is going to be 10 plus I and 10 minus I, and follow the same principle as these conjugates here, and I'm going to end up with a squared minus b squared. In this case, my a being 10, my b being a 1, the coefficient of I. Now it's going to be slightly different though, because the original rule was subtraction. Our new rule is going to be a squared plus b squared. In this case, 10 squared plus 1 squared. We get that from, when I multiply these out, if I FOIL it, I'll have 10 times 10, so I have 100. 10 times negative I, so minus 10i. I times 10, so plus 10i. I times negative I, so a minus I squared. If I combine my like terms, negative 10i and 10i, that's 0. So I have 100. Now, minus I squared. We know that I squared is substituted as a negative 1. So minus negative 1 becomes plus 1. There's my 10 squared. There's my 1 squared. So I get 101, as I do over here. So simplifying the denominator comes down to this expression. Whatever the a term is, square it. Whatever the b term is, square it, and you add them together. And that's with the i's, with complex numbers. Now, you may recall this is very similar to rationalizing radicals, where we use the same principle, but there it's a squared minus b squared. Here, having the I changes that minus into a plus. With problems like this, if you don't remember that you can square each one and add them, if you FOIL it, you'll get the same answer. So this is simply a shortcut that saves you a couple steps. So in this case, I know my denominator is 101. My numerator, I'll have to multiply out FOILing, so I'll get 3 times 10 to get 30. Times negative I, minus 3i. 5 times 10 gives me plus 50i. Then minus 5i squared. Now it's a matter of combining like terms. Negative 3 and 50 give me a positive 47i. 30 is still 30. I squared is negative 1, so this becomes a negative 5 times negative 1. So 30 plus 47i plus 5 gives me 35 plus 47i over 101. Lastly, I want to see, can I simplify any of these three numbers, the 101, the 47, or the 35? So in other words, is there any number that goes into all three evenly besides 1? And in this case there isn't. So I cannot simplify any further. This becomes my final answer. So I simplify these types by identifying the conjugate of the denominator, and then multiplying both numerator and denominator out, simplifying as much as I can.